Very exciting. So we're looking for continuity. So this is telling me that the first piece of the piecewise function does not exist when x is equal to 4. Right? But I would imagine that there is some y value that it would have if it could exist at that location. Right? This is telling me the second piece is saying that I have the equation y equals k when x is equal to 4. Right? There's a couple of ways to handle it. One would be to create a graph, which I would imagine also if you maybe don't want to do that. Right? So let us investigate what the limit of that first piece would be. So we're just focusing on this guy. We'll find the limit as x approaches 4 of this function. Basically saying that I can't get to that location, but I want to know what I'm aiming for. All right. So if I wanted to find this limit analytically, so using the algebra of calculus, what would I do? Factor it. So we'd have x minus 4x plus 4 on top, x minus 4 on the bottom, cancellation. So this would be the same as saying the limit as x approaches 4 of x plus 4, which you could get just by doing direct substitution, gets you a result of 8. All right. So what that's telling me, and I will show the graph just so you can kind of have a sense of what's going on here. It's telling me that I have this line here, the y-intercept of 4, a slope of 1, that kind of looks something like meh. But then at 4 there's a hole. Right, at the x value of 4 there's a hole. That corresponds with a y value of 8. All right. So in the original form, we couldn't figure it out because that gave us something indeterminate. It gave us 16 minus 16 over 4 minus 4, 0 over 0. All right. But now we know what the y values of that location just by finding the limit. So if I want this to be continuous, what I need to do is plug the hole. So if I'm going to plug the hole, I would have to establish a coordinate of 4, 8. All right, the second piece of the piecewise function is telling me that y is equal to k. Y equals k when x is equal to 4. Well, in order for this to work, the y value has to be equal to 8. So that tells us that the k value must have been 8. That's the only way it would work. In order to plug the hole, the k value here, this would have to be the coordinate of 4, 8 in order to make this a continuous function. I have to plug that hole. If I put that coordinate anywhere else, the limit still exists, but it's not continuous. I don't plug the hole. All right?
Is it like always just, would it just be k, not necessarily below, but is it always just like one constant, like just one variable, or can it be more complicated?
Oh, it could be more complicated. It could be like 2k minus 7.
So in that case, what would you do?
Well, you know it has to result in an 8.
Okay, so you just would set it equal to 8.
Exactly.
Thank you.
And you get the 8 by substituting in the 4 because the 4 is because you're approaching 4?
Yeah.
Okay.
All right. Was there anything else from the review that you wanted me to look at?
There's 40 while we're at it.
40? Oh, discuss the continuity. Excellent. All right, so they give us an interval. They tell us that we're looking at a domain of -2 to 2. What I want to know is whether or not the continuity will be the same as that, a slight modification of that, or completely different from that. All right, so the -2 to 2 gives us a place to start. All right, so if we're going to address continuity, we got a lot of things going on, but first and foremost, I want to know where the function exists. All right, so anything that doesn't involve a negative under the radical is going to be good to go. So I'm going to do 4 minus x squared. I want that to be greater than or equal to 0. All right. Subtract, take the root, no, subtract, divide, take the root. You're looking at x squared less than or equal to 4. All right, if I subtract the 4 and then divide by the -1, dividing by -1 is going to reverse the sign. And so x, if I take the square root, will be less than or equal to plus or minus 2. But we talked about this a couple days ago. That means the same thing as the absolute value of x is less than or equal to 2. But really, we don't need to know that as long as we know that we're living in the interval of -2 to 2. All right, which is consistent with our domain, so that's good news. So we have a sense of what the continuity is doing, but the one little additional component that comes into play is that I need to test the boundaries also. All right, so what I need to do, and this is all in your notes, so you can reference it if you want, but I want to find the limit as x approaches -2 from the right. Awesome. So this is the leftmost bound. I can't approach it from the left-hand side because there's nothing to the left of that -2. So I can only approach it from the right-hand side. The right-hand bound, there's nothing to the right of 2, so I can't approach it from the right. I can only approach it from the left. These two things need to exist in order for us to have continuity over that interval of -2 to 2. So, fortunately, it's just plugging and chugging, though. And we don't care what they are, we just care that they exist. All right?
Why both from the right?
Oh, because I'm a fool. I said left, I just didn't get that on paper for some reason. So if I plug in a -2 to the first expression, I just get a 9, right? The radical part cancels out. If I plug in a +2, I just get a 9. These two things, they don't have to be equal to each other. They just have to exist. All right? It does not matter what they are, as long as they exist. Turns out that they're the same, which is coincidental. It doesn't always play out that way. They're only the same because this is a symmetric graph. There are plenty of graphs out there that are asymmetrical, so don't fall in love with this idea. They don't need to be the same. They only need to exist.
So would you do the same steps if the domain that we discovered for the equation was not consistent with the domain given?
Yes, except you'd use the domain that we got from our work instead of what was given.
Okay, so you would just always use what we figure out?
Yeah.
Okay.
All right, so we have a function that's continuous for the interval of -2 to 2. All right, we tested it. It passed all our tests, so we're in good shape. All right, everything in between worked because of all this stuff. We tested the boundaries. They exist also, so everything on the interval will work. Now, if I did, let's say, for example, 2 from the left, and I got a DNE on this one, then that would say that it shouldn't be brackets on the high side, it should be parentheses, because I don't have a solid point at 2 from the left-hand side, right? So this result is addressing the fencing of your domain, domain of continuity.
Wasn't like one of the rules that the limits from either side have to equal like f of x itself?
Yeah, at that point. So if you were to find f of -2, you'd get 9. If you find f of +2, you get 9. So it checks out. Okay. Anything else?
Just like a general question about the quiz, are we gonna have to memorize the like special trigonometric like relationship things? Yes.
Yeah. So I generally don't give anything as like in terms of resources during a test. So there are exceptions to that, but this is not the exception. Right? You get a calculator, a writing utensil, any scrap paper that I have, and your brain, and that's it. All right. So,
Do we need to know like this double angle identity?
double angles help. Yeah. Yeah, you can get around it if you know how to use your calculator the right way, but they help. They help. They make life easier. Anything else you want me to go over forever? I think it's a question that everybody can benefit from.
Are there any, do you have review pages in this, right? Yeah, you do, we talked about this.
Yeah, because